Hello, and thank you for joining us for the final session on the final day of our annual conference. Welcome to the President's Day lecture. If you'd like to ask a question, you can do so during the presentation using the code PRES20@slido.com. There'll be the Q&A session at the end, whereby your questions will be answered. Our host for this session is the Chief Executive of the IMarEST, Gwyn Lewis, and our speaker is, of course, none other than our 118th President, Kevin Daffey. I'll now hand over to you, Gwyn.
Good afternoon, or good morning to those dialing in from overseas to the West. It's with great pleasure that my first public role as the new Chief Executive of the Institute is to welcome and to introduce Kevin Daffey, our President, for his President's Day lecture. Kevin Daffey holds director level posts at Rolls-Royce. He has 29 years of engineering experience, including 20 years in senior engineering leadership posts. Kevin's roles have provided him with considerable experience in mergers and acquisitions, innovation, design for product safety, nurturing capability, developing technology, continuous improvement, and business strategy. He's had a varied career path with roles in industries such as marine, steel, mining, aerospace, defence and power generation sectors. Kevin has led diverse teams across many time zones, including the USA, Europe and Singapore. He's been a chartered engineer since 1999 and a fellow of the Institute of Marine Engineering, Science and Technology, where he started his presidential year in March 2020. Over to you, Kevin.
Thank you, Gwyn, and hello, everybody. Let me just do the final fumbling around to share my presentation, and hopefully, Gwyn, if you can confirm I'm now sharing. Hopefully I am.
That's all fine, yeah. Thank you, Kevin.
Lovely, thank you very much. So, good morning, good afternoon, good evening, wherever you are in the world today. Yes, Kevin Daffey. I'm going to take you on a journey of what I think is going to be the technical or the technology revolution that's going to happen in marine. I'm somebody who's absolutely passionate about technology. The theme of my year is around technology, and what a fabulous conference we've had. It's been absolutely amazing. We've had some amazing speakers, some great technical discussions, both in science and in technology and marine engineering. And we've had over 3,000 people sign up to participate in the conference. Typically, most of the presentations have had anything from 50 to over 200 people that have watched them live. But in some cases, with the catch-up TV, we've had up to 500 people viewing some of the presentations. And I have to say, I've been one of those who's been playing the catch-up because I've got a pretty busy day. I've not been able to watch any of the live lectures. But I've been getting up at 4:30, 5 o'clock to actually enjoy some of the lectures. And I'm going to confess now, I've been using the 1.5 times speed effect so I can get through as many of the lectures as possible. And it's really funny watching Richard Vai talking at 1.5 speed. So I'm going to really recommend at the next Board of Trustees meeting that he leads and chairs that he's speaking at 1.5 times speed. Fabulous. So, who is this president, you may be asking? As Gwyn introduced me, so thank you, Gwyn, for the introduction. Probably took that directly from LinkedIn. I've been in the marine industry since 2001, and I've thoroughly enjoyed being in the marine industry. It's not an industry that I naturally wanted to be in. So the picture there of me with a fishing rod on a vessel is not me, is not really me. That was the first time I've ever been fishing. It was on a fjord in Norway. I was out one evening. The hotel put on a fishing boat. A few of us went out and we tried to catch cod during March. It was absolutely freezing cold. It was good fun and I caught nothing. So that was the end of my fishing career. On the left there, some of you that may be in Wales will recognise Derek Brockware. Gwyn, you might recognise Derek there. He's famous on the BBC as the BBC weatherman. Weatherman Walking is one of his programs, and the only time I ever appeared on television was I actually submitted frivolously a photograph of the River Severn and the second Severn crossing the Prince of Wales Bridge. And it was picked up by the BBC, and Derek Brockway shared it as his image on the weather. So that was the closest I ever got to TV. On the serious side of things, on the bottom there, you've got a couple of pictures of me in the marine industry. I was a director of the Rolls-Royce Marine Division as the Director of Engineering and Technology, and that was thoroughly enjoyable, developing new propulsion systems, deck machinery, automation and electrical equipment and systems. Absolutely fabulous fun that I had. And then I put that business with the rest of the management team to sale, and we sold that successfully to Kongsberg, and Kongsberg have been successfully integrating that and building on the capabilities that we had ever since. And during that time, I was Director of Ship Intelligence. So for several years, I spent with a team in Norway and Finland developing the world's first sort of remote and autonomous technology. And I had the pleasure of being invited to an IMO session. It was the 100th Marine Safety Committee, a special session, and I presented the technology progression around maritime autonomous surface ships. And on that particular day, my team had just done the Swan demonstrator in Finland, where we took 150 special guests on a ferry which was completely autonomously controlled over on a crossing and return remotely. And I played the video to every nation that was represented at the IMO, just to say to them, remote and autonomous technology is coming about. And that was a really special day, being able to speak in front of them. And I'll talk a little bit about that and that sort of technology a bit later. I've also worked in the Ministry of Defence, a lot of activity in the naval field. I was a regulator in the Ministry of Defence as a naval authority for power and propulsion systems, and had the pleasure of giving certificates to a number of the Type 45 destroyers. But I also helped develop technology with the US Navy and the UK Navy, and also developed safety systems as well. And currently I'm here in Germany. I'm based here with MTU Friedrichshafen. We manufacture high-speed diesel engines for the marine industry, as well as power gen and for industrial and construction vessels. We design propulsion systems and do automation systems. So I'm here out of lockdown now in Germany, and broadcasting to you all. So what I want to do today is I want to just take you through what I think is going to be some of the future technologies over the next 10 years. I'm really focusing on the next 10 years. And I just think this is going to be a really profound period of time for the marine industry. We've got a lot of challenges, engineers, technologists and scientists to get through this next 10 years. But I think as a community within the IMarEST, we can do that. So let's first of all talk about remote operations and autonomy. It's an area that I have a high degree of expertise in, but it's an area where I see a lot of investment and a lot of technology going into, a lot of intellectual capability. It's an area that has got lots of opportunities, but it's recognized as another area that has lots of challenges. So what do we really mean by autonomy and remote operations? So the best way of describing it is we're looking at what roles we can take on the ship and moving them to shore. And the reason that you might want to do that is you might want to remove humans from risky scenarios. And in some ways, some of the industry has been doing this for many years. If you look to the offshore industry, there's been a progression of people on anchor handlers rather than working on the deck at the back. Their roles have moved into the bridge space, and they've been using robots and cranes to help them to deploy anchors to tie down floating rigs. And this has really had a profound impact in improving the safety in the North Sea. So it's something that we're used to. You know, if we can do that and we can make the marine industry much safer, then why shouldn't we do that? The other thing is it can give us the opportunity to design ships differently. We can gain more degrees of freedom. If we get rid of all the habitable areas on board, get rid of all the life-saving equipment that we have to carry, you can actually design ships in a much different way. And I'll come on to talk about that a little bit later on with what the Navy vessels are doing in this particular area. The other thing around autonomy is we can begin to capture and automate best operational practice. So operators can codify the way that they operate, and they can capture their best practice and repeat that best practice more and more without having to train people how to do it. The humans may be making mistakes, etc. So really, it's a great way of capturing knowledge. And we can remove humans from some of the more risky elements that are being done. And Richard Vai gave a good presentation, the very first one in this conference, talking about the human element. It's quite interesting because he's talking about the fact that quite often, in terms of the user interface and from the machine to the human, quite often we get that design completely wrong, and therefore the human is predisposed to making mistakes under certain conditions. And quite a lot of the accidents at sea that are attributed to the human element, it's not a human error, it's actually down maybe to the user interface and that machinery. But again, if we can get rid of that need for that interface, again, we reduce the risks. And I feel it's an opportunity to exploit our knowledge, capture best practice, and we can do that from other industries. In the mining industry, mining trucks have been going autonomous for many, many years now, and we can learn from, quite a risky sort of industry. Power generation, we've had remote working in power stations for a long time. Power stations have been controlled from central control stations. Rolls-Royce had some control stations for some of its gas-powered power stations for many years, operating from a control centre in Derby that then controlled power stations up in Newcastle and down in Bristol, and also in London. So, why not learn from other industries that are doing this? And, the automotive industry at the moment is doing a lot of work in autonomy. The medical industry is also looking at using autonomy to perform some sorts of surgeries. So we've got a lot that we can learn. And I believe that it's a really great use of human capital. We can actually begin to centralize some of our human capital into remote operating centers. And it's a good way in which we can actually utilize our human capital. And when we talk about autonomy, there's lots of different ranges of doing autonomy. Quite a lot of people think about robot ships and ships which are completely unmanned and have their own decision-making capability. Yes, that's one end of the scale. But there is a whole host of different of applications of autonomy that don't necessarily mean complete automation. And there's been quite a lot of work going on into sort of scoping, well, what is the different levels of autonomy? So level 1 is quite often where we rely completely on the human. There may be some small amount of automation, but actually the human makes all the decisions and makes all the controls. Level 2 is where we begin to provide some insights to the human operator, and at that point, some of the decision making is still with the human, but more and more information is given automatically from data collection to that human being. Level 3 is where we start to give some of the automation, some of the the more regular tasks. If you think about this as your sort of your speed cruise control on your car, for instance, you convey that task to that on board your vehicle, but all the time the human can take control at any time. Level 4 is where we begin to give a lot more of the machinery over to automation, and the crew then really watch over it, and at that point they're really supervising, and they will only intervene where necessary. And level 5 is where full functionality and decision making is given to the automation. And of course we can flip between any one of these, and for instance we can move from level 1, a sort of a manual control. We can give automatic control to the vessel, we can watch over it, and then we can then convey trip control back down to the human, back to level 1 very, very quickly. But clearly there can be some impacts of this, and it's been tried in other industries like aerospace, where the autopilot is in control, but when the autopilot says it can't control anymore because a speed sensor has not worked, or something is not quite right, it will trip out and give it to the pilot. And at that point, the pilot, if he's not really ready to take control, there's an opportunity for accidents to happen. So there's really quite a lot of activity we have to do to make sure that we can make this technology as safe and as reliable as possible. Just to give you some ideas of the sort of the level 2, situational awareness is one of the key technologies that we need to make autonomy work. Situational awareness is where we start to use sensors to give us some idea of what's around us. to identify what's around us, and use that to give us insights into what it is that we can do about those targets, as it were. One of the challenges in container vessels is the maximum height in which you can load in a container vessel. And SOLAS, for good reasons, means that you need to have a minimum line of sight visibility from the bridge for watchkeepers, and that's 2 ship lengths or 500 meters, whichever is less. And that will limit the amount of containers that can be loaded up at the forward end of the vessel. But why not fit a situational awareness device at the very front of the vessel? And that would allow you potentially to then bring an augmented reality set of screens in front of the watchkeepers, who can ultimately see through those containers using the situational awareness package. They'll be able to see through weather conditions. They might be able to see more things immediately in front of the vessel as well. And it will provide insights to the watchkeepers in terms of what they do. So, you know, this is a technology which is almost there. And actually, for less than $1 million, this sort of technology could be fitted. And the payback in terms of the additional cargo that can be carried, the payback can be made in probably a couple of voyages. And there's certainly quite a lot of activity. Maersk have been working with Sea Machines, work that was going on within Kongsberg in this area as well, to look at whether this technology could be implemented. Implementation with the technology is relatively easy, but then it's getting it through the certification and the flag states to allow it to be allowed on vessels in their ports and in their waters. Huge amount of activity has been going on in tugs, and the bottom graphic there is a project that I was involved with for a long time with Svitzer. It's the Svitzer Hermod that operates in the port of Copenhagen. And Svitzer came to the team that I was running at the time and talked to them about the opportunity to do a remote control demonstrator for one of their tugs. And we took up the challenge, and within about 9 months, we kitted out a remote operating centre, and we actually operated a tug in the port of Copenhagen under remote control. There was a crew on board at any time that could take over. That was part of the regulations that the Danish Maritime Authority imposed on us. But again, we proved the technology, and we did a second set of demonstrations a year later, where we provided more automatic functions and greater degree of remote control to the remote operator. And that project continues. And there's been more work popping up over the last few months. PSA Marine have been working on a tug. Keppel have ordered a tug. ST Engineering have tested a tug in Singapore. And Robert Allen recently have been working with Abu Dhabi Ports, and the middle picture there is of a graphic of one of the tugs that they hope to design and therefore build in the next 5 years. You might ask yourself, well, why on earth do we want a remote control tug? You know, what's the benefit there? Tugs are not cargo carrying. It's a difficult application. It works in close confined waters with other vessels and other obstacles. Well, tug operations can be quite risky. There have been lots of accidents involving tugs, not least from tugs that have broached and flooded, and people have drowned, crews have drowned. Just throwing down the monkey fist onto the deck from the vessel that wants to go under tow has caused injury to people when it's hit them. And therefore, if there's any way in which you can move the crew away from the tug and put them onto shore, then there's going to be a benefit there. Crew flexibility is another area that could be of benefit. And the other thing about tugs is they operate in harbours, in cities, and therefore communications is actually relatively easy to do. 4G networks are available, even wide area wireless systems. That means you've got diverse communications. You can get a lot of data to and from the tug, as it were. And it's very close to shore. You can recover the tug, you can get it alongside, and you can do maintenance to it. One of the questions is the technology cheaper? So part of the rush at the moment to do these technology demonstrators is to get the technology down to an affordable amount for CapEx. But certainly studies which have been done on the OpEx mean that there is quite a lot of big benefit here. And the fact is that, that this is now seriously being looked at and will be a technology that will be deployed in the next 10 years. I'm pretty confident of that. Just carrying on with the theme of announcements, lots and lots of different regions around the world have been making announcements about investments in autonomous technology, even within the last 3 months. I just went through and had a quick look at the Marine Professional News and some of the other trade press. In Norway, ASKO Maritime have actually ordered 2 ferries, which are going to be operating in Oslo, which will be autonomously and battery powered. In Japan, there are 3 different programs going on involving industry partners, with Mitsui OSK looking at container ships and ro-ros, putting investments, hoping to get autonomy working on some of their vessels in the next 3 to 4 years. A big program called DFFSAS. It involves 22 different Japanese companies working together, designing the future autonomous vessels. Mitsui Shipbuilding are working with a ferry company to develop autonomous ferries as well. Japan is an interesting region because it has a huge maritime history. Transportation on land is quite difficult. So actually coastal cargo is something which is really important to Japan. And actually automating it, making it green is a big theme. So there's actually a really big regional a desire to move to using autonomous technology. South Korea, again, is putting about $160 million into ocean-going remote control ships, really supporting its shipbuilding industry and its long history and pedigree of exporting to the rest of the world. The EU is not being left behind. The auto ship program was conferred on a number of different companies over the last few months, looking at short sea shipping and inland waterways, also looking at developing shipping lanes. And there's a consortium of companies that are now developing autonomous guard vessels for offshore renewables to guard those offshore renewable sites. And even the UK has put a modest amount of research grants to smaller companies and universities to develop some of the enabling technologies as well. Probably the biggest impact out there could be China, and research that's been done by Tatus recently has identified that they've actually put down almost 3,000 patents over the last 5 years with both industry and academia in autonomous shipping technology. China, when it puts its mind to something, will deliver, and we're pretty certain that that a lot of activity and leadership will be developed in this area. And for China, this could be a big export potential for it and its shipbuilding industry. Some of the demonstrators it's been doing, Guangdong has been announced as a huge test area, 770 square kilometers of it. The autonomous cargo ship, so Yangzhou technology. The picture at the top there is this simple vessel which has been used to demonstrate harbour-to-harbour transport of a single container. But the Zhuhai port has ordered 19 of these cargo vessels, and it will be using it for transportation, I think, around the Hong Kong region. Navigational brilliance, again, looking at container vessels. They've tested some of their navigation technology recently on one of the vessels. They're now in the process of building an autonomous container ship, which will carry 300 containers. That should be operating next year with a view to building bigger and bigger ships. So over the next 5 to 10 years, I think we'll see China slowly overtaking the Europeans in this area with both their technology and actually the advancements of vessels which will be autonomously controlled. The navies are not getting left behind. The naval have been very interested in autonomy for many, many years. Mine countermeasure vessels have been using autonomous technologies for a while now. ROVs have been deployed by navies. So the navies are reasonably comfortable with it. And even in, of course, their air forces using unmanned aerial vehicles, the Reapers and the Global Hawks have been used for many, many years. So in many ways, the armed forces are absolutely used to this sort of technology, and it's something which they see as an area that they would naturally go into. And clearly the US Navy are now really beginning to make great strides into unmanned surface vehicles. They really want a set of autonomous ships which can fire and reload absolutely automatically. A number of different programs going on there. There are literally dozens of these programs if you include all the countries. But if we just talk about a few of them, so NAVSEA have been have got this Ghost Fleet Overlord set of test vehicles. These are commercial vehicles, but they're sort of a precursor to medium-sized USVs. They've tested 2 of these, and one particular test, it was a 4-day autonomous test. They claimed it did 181 hours without any human intervention, covered 3,200 nautical miles, completely compliant with the collision regulations. And these are preludes to what they call the large and the medium unmanned surface vehicle programs. And the US Navy are now ordering a new medium unmanned surface vehicle. They ordered it last year. It will carry 2 containers, a 40-foot and a 20-foot ISO container, be able to do 4,500 nautical miles at 16 knots, have a 15-year service life. And then earlier this year, they put out an RFP for a large unmanned surface vehicle, and this is going to be for a construction later. And it will be something of the order of a corvette, small frigate size, capable of launching missiles, both anti-ship, anti-submarine, and anti-aircraft. And the US Navy are looking potentially to order 8 more of these types of vessels over the next 5 years. So within this next 10 years, we're going to have, autonomous naval vessels out there on the ocean. The UK has developed some technology with BAE Systems on a Pacific 24 vessel. This is going to be used for anti-piracy, border control, force protection. It can be deployed from a variety of different ships like the aircraft carriers or other sort of Type 45s or other vessels, and it will be used to support its own vessels. Sea Hunter at the bottom picture there, that was one of the original DARPA programs that was a 132-foot vessel trimaran that did 27 knots, completely diesel powered. And a program called NOMARS, no crew, no mariners on board. Its idea, and it's the picture in the top right, is a simple artist graph of it. And DARPA want to start from a clean sheet of paper. They don't want any human habitability on board, and they're saying, right, what can we do in terms of a ship design when we don't have to build it with any thought for the human being on board to be carried at that point. Future autonomous ship market, within this decade, lots of projections. Just did a quick search, and anything from 11 to 15 billion over the next 6 to 7 years. Some amazing claims of $130 billion market by 2030. I'm a bit skeptical about whether that really is, but certainly, all the omens are there that this market will pick up and the supply chain will begin to feed into it. Will the ship owners really want this technology? Well, I think, we're beginning to see it in the tug market. We're beginning to see it in the ferry market. And this is my prediction of where we will see autonomy really picking up over the next 10 years. And it's going to be around coastal waters, because we know that going from one country's waters to another country's water using the open ocean at the moment is not permitted for autonomous vessels. IMO are still looking at this one. They've been doing a scoping study at what the rule changes would have to be. So low probability by the end of the year we'll see the larger ocean-going vessels with autonomous, but we will certainly, with high probability, because we're already beginning to see it, we're beginning to see the technology taking off in coastal waters and inland waterways. Lots of challenges, and actually a lot of the challenges have been covered in this conference to date. So some really, really good presentations. I watched this morning Phaedra Gibson talking about humans and autonomy. If you've not seen that presentation, you will be blown away by some of the things that she's talking about. The sort of the mind and body sort of interface to a computer, some of the drugs that could be used to enhance human performance in human behaviors, some really amazing sort of things for the 2030s, 2040s and 2050s, and really discussing some of the issues around the ethics, etc. Actually, where some of the challenges have been really overcome is in the offshore industry, and I was really pleased to see Fugaro do a great presentation on their remote and autonomous operations that they've been doing in the offshore. So Etika Robrook, Shabin Hanif and Ross McFarlane give another really, really good presentation on Wednesday, talking about what they've done. They've got 8 remote operating centres around the world. They've helped numerous clients around the world using these remote operating centres. And actually COVID has been an accelerator for many of their clients moving towards this sort of technology to get things done in gas pipelines, oil platforms and other offshore facilities. So clearly there's a challenge around the human and machine. Watch the Richard Vye lecture if you want an opinion about autonomy and humans and machines. Another one is trust. We'll come on to trust a little bit later in the AI section. We might have new hazards that we've not thought about. When we introduce new technology, we have new hazards. Ethics is another big issue. It's certainly plaguing the automotive industry. Quite often is cited the sort of, do you run over 5 people or the woman with carrying a pushchair in the event of an accident that's unavoidable. Also, the cost of the technology is another area. Is it going to make ships more expensive and therefore it's going to slow the deployment of the technology? And the final one is something that came out of the presentation when I gave to the IMO. I had some of the countries ask me the question, who's going to be disadvantaged because they cannot access the technology? So there are certain countries around the world that do not have this capability, and therefore they think through export control and other sort of government restrictions that they may not get access to technology and they could be disadvantaged. So again, lots of technology challenges, but also some political and ethical challenges as well. Shipping and greenhouse gases. So we've had quite a number of presentations that have covered this area in a lot of detail. I'm just going to go into a few things. So first of all, let's just remind ourselves, the IMO have set themselves a target of reducing the global greenhouse gas emissions from international shipping by 50% in 2050 compared to 2008. This is quite an ambitious thing to do. We're not really sure how we're going to get there. But certainly, and there's also some midterm targets as well to reduce emissions even by 2030. There's been a timeline published, and I'll refer you probably back to the presentation gave by Captain Mohammed Shafiq on alternative fuels for emission controls, where he went through the timetable and talked a little bit about the sort of ship energy management, efficiency management plans, and the energy efficiency index as well. They're beginning to drive through a great deal of help in terms of the industry meeting its target. But the big thing is that there's a big expectation in this green area from the IMO that technology somehow is going to help us get to this very ambitious target of halving the greenhouse gases, or even meeting the ambition of actually going carbon zero or carbon neutral by 2050. Lots of ways in which it can be done. I'm not going to go through this one, but again, I'd refer you to Maddie McLean and John Butler's presentation, where they actually took a view around how do I get shipping that is at what we call absolute zero, where we create no emissions in the operation of our vessels. The class societies have been busily publishing lots of views around alternative fuels and efficiencies based upon them working with the equipment suppliers and the shipbuilders and their unique position in regulation. And and this is going to be a real challenge for the class societies to stay up to date with all of this different regulation. Again, going to Maddie McLean's presentation, she went through quite a number of the technologies which are around at the moment. In her view, they are ready now, ready for deployment. So go and have a look at that presentation if you want to get some sort of insight into some of the technologies, particularly things like foil propulsion, wave propulsion, water electrolysis, fuel cells, and solar panel for the marine industry. Let's just have a look at one or two of them. One of the ones I'm quite excited about is hull air lubrication. It's a technology that's been around in some cases for over a century. People have already thought about, if I could run a vessel on a cushion of air, however I generate that air, it's going to reduce its friction and it will make it flow easier through the water. And you can do that in a number of ways. You can inject an air film, which effectively is this diagram at the top here. You can have an air cavity like an upside down swimming pool underneath the vessel, or you can inject what we call microbubbles into the boundary layer, which effectively reduces the friction of the vessel. And a company in the UK, Silverstream, have been pioneering this technology. And what's exciting is not the fact that they've done some demonstrators, is the fact that they're now looking at completely industrializing this technology and actually selling it on large scales. And they did a deal last year with Wärtsilä to absolutely market this technology through their own channels, sales channels, So I can see this technology really taking off over the next few years, and the benefits are anything from 5 to 10% reduction in power for the same ship speed, and that could have a real benefit in terms of reducing fuel and reducing CO2 emissions. Marine fuels. This is an area which is close to me, working for an engine manufacturer, is really knowing which fuel is going to be the dominant fuel in the future. We've been very lucky there, we can develop the technology, but we are really at the limits of what we can do with diesel engine technology in terms of making it more efficient, reducing the emissions from it. You know, it really is at the sort of at the limits of what we can do in terms of a fundamental set of physics. So there are lots of different marine fuels out there, and the challenge for both us that make equipment like diesel engines, for the people that run and operate fleets and run ships, is knowing what is going to be the future fuel. And I think the next 10 years is really where we will see lots of discussion around it. We'll see the development of some of the fuels, but I think we'll probably hone in on one particular set of fuels that we will use for the future. This is a mimic that's come from Bureau Veritas. I think it's quite good because it sort of classifies the fuels into 3 different parts. So first of all, there are those that are based on carbon fuels. So if we get diesel and heavy fuel oil, we've got natural gas, which has got lower emissions, but again, it's not the carbon neutral fuel, it's a transition fuel. Liquid petrol gas, petroleum gas, methanols and ethanols, which are created from carbon fuels. So although they're clean fuels, the fact that you've actually generated them from processes involving hydrocarbons means that you're not really getting the benefit of CO2 reduction. Then you've got carbon neutral fuels. So these are coming from biofuels, where you're capturing carbon in plant material, you're creating a fuel from it, and then you're burning it. So the idea is the cycle is broken in some way, and synthetic methane is another one. And then you've got the pure zero carbon fuels, hydrogen and ammonia, where you're not creating any CO2 at all. You're not doing that emission. But these only work where you generate the fuel from renewable sources. And we'll go into that in a bit more detail. Power to X is a term that's being bandied around a lot at the moment. So this is where we use renewables to generate a whole host of energy and fuel types for different applications. It could be for mobility, it could be generating fuel, it could be for chemicals, it could be for power generation and heating. So this is where we take renewable energies, we can use it directly. So for instance, if we look at Norway, it's using hydroelectric power to recharge batteries on ferries. The ferries do their transit across the other port, they get recharged again. It's a power to electricity mode of transport. It's power to mobility, completely green, no CO2 emissions, and it's being used from renewable sources. You can then go through an electrolysis process. You power electrolysis, you break down water, you create hydrogen, and from hydrogen you can then either use that as a fuel for heating or for electricity or for other things, or potentially you can use it to generate other fuel types like methane or chemical products or liquid products, as it were. Power to e-fuels, something that the car industry is getting interested in. You can use the normal reciprocating engine. You generate an e-fuel from a chemical process where you take, you get hydrogen from renewables. You then get carbon capture, and you create the fuel, you burn the fuel, you create CO2, but you capture the CO2. So it's a sort of a carbon neutral approach to generating fuels. What's got me really excited is in the last 2 weeks is the announcement by the Saudi government and Air Products on the construction of this $5 billion multi-scale creation of green hydrogen and ammonia facilities. And it's going to be built in northern Saudi Arabia. And the idea is that Saudi Arabia wants to be able to become a net exporter of hydrogen to the rest of the world. And it was unveiled a couple of weeks ago. It should be on stream by 2025. It's going to generate 650 tons of green hydrogen using sun, wind, and water. Hydrogen is going to be extracted from the water. Nitrogen is going to be pulled from the air, combined with the hydrogen to create ammonia. And what they're going to do with the ammonia is use it for transportation. It's much easier to compress and transport ammonia. It's very similar to transporting LNG. You export that, and when you import it, you then convert the hydrogen, you convert the ammonia back to hydrogen, and you can use it in any of the power to X types of mode. And I think the fact is that a big country like Saudi Arabia is doing this at scale means there's going to be an abundance of hydrogen and ammonia fuels, and that may be the game changer. That means that we then settle down on the two types of fuels that could be used in the marine industry over the next 10 years. A number of other nation states are also racing to it, and this is the bit that really gets exciting. So almost every week, another nation is producing their hydrogen economy strategy. Germany have done it, Netherlands, Portugal, Norway, South Korea, Australia. Australia are looking to use Western Australia to go from solar to hydrogen. The EU have announced something like €50 million investment in electrolysis over the next 5 years, and then looking at investments in technologies to make hydrogen economy up to 2030. I was talking to officials from the Scottish Government about their hydrogen strategy. They're looking to move away from the dependence on fossil fuels in Scotland towards using hydrogen. Huge abundance of renewable offshore wind and tidal energy, which they've got excess of at the moment, which they could use to generate hydrogen. They're already powering all the buses in Aberdeen using hydrogen. They're thinking about using it for train mobility. And they're also talking to a number of players about, could we do this in the marine industry as well? And John Butler, I know one of our esteemed fellows, is looking at this in the North Sea about generating hydrogen from renewable offshore wind. Germany also produced its national hydrogen strategy. It's allowing a transition using hydrogen generated from fossil-based means, but it sees that only as a transition to move in itself. And when one of the world's biggest economies actually moves towards using hydrogen, these are the sorts of game changers which will mean hydrogen will become abundant. The price of hydrogen will come down as well. Lots of different flavors of hydrogen. So, when people talk about hydrogen, they might talk about blue hydrogen, green hydrogen, low carbon, fossil-based hydrogen. The two that we're really interested in is what we call clean hydrogen or blue hydrogen, which is effectively renewable hydrogen. Hydrogen generated from renewable sources that we can use, which means that it really is a carbon neutral, carbon zero fuel. How are we going to use the hydrogen? There are two ways. The first one is using fuel cells. Again, fuel cells is not a new technology, but the recent announcement, I think, by ABB with Hydrogen de France, HDF, to develop the ABB and the Ballard proton exchange membrane fuel cell at scale in megawatt units that could be used in fuel in cruise ships or container vessels is a game changer. When the big companies come along and they start to industrialize this technology, we now have a pathway in which we can actually utilize this, and we can see this being rolled out in scale. On the left-hand side is my own company. So that's one of my colleagues, Dr. Martin Tigler, signed an agreement with Daimler to take their fuel cells from the automotive industry, which they've been developing, very compact fuel cells. We're going to use this technology for data centers, for green energy for data centers, but we could use this on the smaller ships that we tend to provide power units for, like tugs and workboats. And I think the fact that the huge series scale industrialization we see in the automotive industry, taking that technology, it will be lower cost, it will be ultra reliable, it will be ultra safe. Taking that industrialization is going to be a game changer for the marine industry. You can also use it in reciprocating engines, and an interesting project going at the moment is Hydrotug, the world's first hydrogen fuel tug. This is a Belgian company going to be used in the port of Antwerp. Hopefully, I think by 2021, it's not clear when it's going to be delivered, but effectively, this is going to be a reciprocating engine, which is going to be burning liquid hydrogen. I'm quite interested in this, being a reciprocating engine person. We've had a single cylinder test demonstration using hydrogen. There are some challenges with hydrogen in liquid format. You have to cool it down to less than 20 degrees Kelvin. You store it at quite high temperatures. At very, very low temperatures, you can get embrittlement of material, which can make the injector technology quite interesting. Also the safety of it, ventilation and gas detection can be quite slow. So you might be might lead to an explosion, very wide flammability. So there's a number of challenges to be overcome when we put this into the marine industry, but that's not to say we can't do it. So this is an interesting project to watch. And just another interesting variation of wild and wacky technology. Why can't we just capture the carbon and freeze it and then just sink it to the bottom of the ocean? So you can burn conventional fuels or any of the newer fuels, the e-fuels coming out. And a company or a consortium of companies called Decarbon Ice are genuinely looking at this. They're looking at building cryo units, condensers in the exhaust of conventional engines using a cryo cooler, creating dry ice effectively, shaping the dry ice, and then dropping it off the back of the vessel. It will sink because it's heavier than water, and effectively that dry ice permeates the seabed and it's stored permanently in the seabed as CO2 hydrates. I have no opinion about whether this technology will work or whether it's the right thing to do. But again, people are looking at this sort of innovation, and maybe this is a quick way of cleaning up existing vessels. The sort of penultimate topic I'm going to talk about is artificial intelligence. And it's quite an interesting area. And I've set up a working group to look at artificial intelligence within the IMarEST, because I feel that there's a huge amount of benefit that we can get as an industry from this technology. And it's all around us. Every day you are interfacing with artificial intelligence. Artificial intelligence is used for sorting your emails, for getting rid of spam, identifying, authenticating emails, for instance. If you use Gmail, it's using artificial intelligence to look at your emails. If you go to Facebook or Twitter or any of the social medias, your post will be arranged based upon the artificial intelligence knowledge about what you like. It puts the right adverts in front of you to maximize your desire to buy those products. LinkedIn uses it to try and match candidates to job adverts. When you interface with people like travel agents, or you book your hair appointment online using chatbots, this is artificial intelligence. Facebook is using it also to detect from the posts that people make whether people are at risk of self-harming, and actually using it to alert mental health services in some countries. Probably the biggest use of artificial intelligence is web searches. Amazon product recommendations are also doing it. Probably really the most interesting one is the fact that many of us use Netflix, and 80% of what you watch is down to the recommendations that Netflix artificial intelligence has put in front of you. So actually Netflix knows what you want to watch, and it's actually enabling you to watch those things. So again, is it chicken or egg? I don't know. Your Face ID on your phone, which unlocks your phone based upon your face. And also security incorporations on the IT networks. There's protocols like Darktrace, which are looking for changes in IT behavior. They're looking for subtle changes that either detect whether somebody's account's been taken over or whether that person is an insider threat. Very sophisticated artificial intelligence. And the picture in front of you now is these digital voice assistants that many of us got over the last 2 Christmases. And we talked to Alexa to play music or to ask what the weather's going to be like. Facial recognition is something which is becoming more prevalent with artificial intelligence. Border Control are using it now. When you go through the e-gates, it's looking at your face. It creates a mathematical picture of some of the features of your face. It maps that to your passport photograph, but at the same time, it will match you also to other databases. Maybe you've made another application for a passport. Maybe you're on a wanted list. All of this is speeding up the identification of people that could be a threat to national security. Lots of predictions on what AI will do over the next 50 years. There are predictions that maybe around about 2050, artificial intelligence will get so intelligent that it will be able to take on and be better than any other human being at their task. And it's certainly getting quite good at playing games. It can do facial recognition better than human beings. It can begin to create dictionaries, languages, and certainly over the next 10 years, we're going to see a huge amount of investment in artificial intelligence. And in marine, these are just some of the examples of things that I've seen it actually being used for. Anything from vessel design, fleet optimization, navigation of autonomous vessels. It's been used in deep sea mining robots for autonomy, tracking marine mammals, weather forecasting, climate modeling. Lots and lots of applications already, both in science and in the design and operation of ships. Robots could be another area where artificial intelligence comes together. This is just something that very recently was on the Marine Professional News. Spot, and it's a robot by Cognite and Aker, and it's being used to capture high definition videos and take readings in inaccessible or dangerous parts of offshore platforms. Why can't we use robots and artificial intelligence to replace maintainers? Why can't you put a robot down into the machinery space? Once it's been trained, it's not going to make any mistakes. It's always going to be on call. It's never going to tire. It's never going to be complaining. It doesn't need shore leave. So, you know, there is no reason why in the next 10 years we can't see the deployment of some form of robotics to help us in the machinery space. If we look at automotive, we use robots to help operators to do complex operations or to do heavy lifting. And this could be one of the areas where we get collaboration between robots and humans, maybe in the machinery space or the maintenance alongside. But of course, who's going to maintain the maintainer is the obvious question. If I don't get asked that question today, then there's something wrong with the audience. But clearly, there is always going to be the problem of who's going to maintain the maintainer. Picture there of Red Dwarf, one of my favorite programs, and the Scutters. People might remember they absolutely went mad one day and interfered with all of the electronics on board the Red Dwarf vessel. And picking up the Red Dwarf theme as well, the arts and cinema has been you know, absolutely perplexed and amazed by artificial intelligence and when artificial intelligence can go wrong. So what are the challenges around artificial intelligence? So first of all is having the IT and the communications infrastructure to get data around to actually utilize it in the marine industry is going to be quite interesting. How do you certify it? It's a sort of, it's designed to be non-deterministic. It's designed to change in terms of its behavior. How do you go about certification? And that's part of the subgroup that I've asked Bernard Toomey to run for me, getting some experts in the industry to get a position for the IMarEST to look at certification in the marine industry of artificial intelligence. And this comes back down to trust. How can we trust it? Are there biases? How can we explain how it works? Because if you're going to certify it, you need to better explain it. How do we test it? Data quality is another issue, you know, getting the right data in, the right amount of data, the right units, the right readings. That is going to be a real challenge for artificial intelligence. And developing new expertise of how to handle it and the methods to do it and the software tools and the frameworks that go around it. And clearly there's investment and certain nation states are putting a huge amount of investments like China into artificial intelligence, maybe leaving other countries behind. So also legal concerns, privacy, compliance, data regulations. These are all important factors in the challenges around artificial intelligence. One of the final themes I'm going to pick up is around ocean plastics. You know, this is something which is a real tragedy in our oceans at the moment. 150 million tons of plastics are claimed to be in the ocean, and we're adding to it with 8 million tons a year. Quite an interesting one. I don't know if you know Point Nemo. This is the most isolated location on the planet. It's the furthest point from any land in the area, and it's the spaceship graveyard. So when spaceships get deorbited, we aim for this area of the ocean in the Pacific. And this will be the final graveyard for the International Space Station when it comes down around about 2025 to 2028. And at the moment, there are over 260 different objects that have been parked in the ocean there from space. But actually, space is not the big polluter there. It's actually plastics is the big polluter. And an interesting technology I picked up is the Ocean Cleanup, a company based out of the Netherlands, which is aiming to clean up 90% of the ocean's plastic. And this is a great project, and they're building these sort of scooping up ships, which are completely solar powered, and their claim is that 80% of the plastics is actually being generated by 1,000 of the rivers around the world. So if they can begin to scoop up the plastic before it gets into the ocean in the rivers, then we've got a chance of actually preventing that pollution getting into the oceans. And it's actually working. This is a photograph of one of their vessels operating in Malaysia. And they're also looking at using it at sea as well. So this is a screen that they set out. It's pulled along by a parachute anchor. An offshore vessel is then chartered to then bring the plastics ashore, collect it all up. And this type of a very, very simple technology could be a real game changer in terms of cleaning up our oceans from plastic. So let's really get behind this technology. And a lot of large companies are actually putting a lot of their sustainability funding into these types of projects. And finally, I can't really be president and not talk about the people that make up our technologists, our scientists and marine engineers, and the impact over the next 10 years. A great area, I think, where we're going to be able to bring skills from other industries is remote operating centres. So the more that we use remote operating centres for operations, for maintenance, for operations of vessels, for fleet optimisation, that's going to allow us to bring diversity and talent from other sectors into the marine sector, because people will be able to, be familiar with the ways in which our technology works by using it in other industries. And I think that this is going to be a great way forward for getting multi-industry skills. I come from a number of different industries. I've worked in a number of different industries, and you can transfer from industry to industry. You don't have to have worked in the marine industry for 20 years. You can adapt, you can move across. And this is where we're going to have to try and attract some of our skills. And we're going to have to try and capture our knowledge as well. With fewer talented people available dedicated to the marine industry, how do we capture that knowledge? Things like machine learning and artificial intelligence will allow us to capture that knowledge. But one of the key things is dealing with change, and that's a topic which I think we could do a lecture on its own, just dealing with change in the industry. I mean, COVID-19 has created a huge foundation for change. Many of us didn't realise how useful remote technology was, remote communications, home working was. We didn't believe that we could do it, but we've been forced to do it, and we did it very, very quickly. There's going to be a huge amount of change in the industry around the different fuels that we use, how we handle it. There's going to be huge change around the level of automation and the number of jobs which are going to be at sea versus the number of jobs which are going to be on the shore. And that's going to potentially bring profound mental health challenges in the marine industry. If there's fewer people on board a ship, maybe people feel that they're lower skilled, their skills are not really required because the real skills are in the remote operating centre. So again, how are we going to deal with the change? How are we going to convince people that they still have a good career when they go to sea? So, this is a topic which I think we could probably discuss for many hours. My plea to you as marine engineers who are members of the marine science and technology community, you're members of the IMarEST, is you've got access to the special interest groups. And my big plea to you today is to actually contribute to this technology debate, help steer it, and help shape our industry by getting involved. The more people that are involved in our special interest groups, the bigger the voice that we can have. Remember that we have NGO status at the IMO. We are big influencers. When we make statements of the IMarEST, it has impact, and you can do that through any of our special interest groups. All of them are run by volunteers, but these are volunteers with huge abundance of energy and passion to make a difference in our industry. So that is all of our special interest groups today. If you see a gap, start one. There is nothing to stop you starting a special interest group. The more that we have, the more vibrant the community is. These are communities which help shape IMO regulation. They run conferences, they share knowledge, they make statement papers, they help other industry relevant bodies make decisions, and they're big contributors. So you are making a contribution through your voice at the IMarEST, through the special interest groups. Get involved. They've done a tremendous job providing the presentations that you saw here this week and last week, and they will continue to develop your learning for you as members of the IMarEST. And for those of you that are not members of the IMarEST, my plea to you is make a simple consideration of why don't you join our community. We represent nearly 20,000 marine scientists, marine engineers and marine technologists. The bigger our community is, the bigger the voice that we have. We're here to promote scientific development in engineering, science and technology. We're really here to provide the exchange of ideas. We're here to uphold standards and status. You can become a professional engineer recognized in many different countries and widen your knowledge. And you'll network with a community of people that are like-minded and want to do the same things as you. So as president of the IMarEST, my final word to you all is think about becoming members of the IMarEST, join our community and shape the future. And with that, Gwyn, I think I will close and open the floor to questions.
Well, thank you, Kevin. What a fantastic and inspiring summary of all the technical, environmental, social changes that will affect everybody involved in the maritime industry. I think it's the first presentation I've seen that has covered fields as diverse as autonomy, innovative technologies, alternative fuels, AI, and finishing off with ocean plastics. So very well done indeed, and thank you very much indeed. We've got a number of questions. I'll run through them. None on geography or history, though, I'm afraid.
That's my preference.
It's from Roland Rogers. AUVs were not mentioned. Does this mean they are not important, especially as naval AUVs are being built in excess of 20 meters length, diving to more than 2,000 meters depth and with nuclear power?
Yeah, it's a great question, and also the offshore industry have been using this technology for decades. So using umbilicals, but moving across to underwater ones. I think yes, it's probably a sort of a good spot really that I didn't put it in. It wasn't deliberate. It was really just trying to cover a range of technologies within 1 hour. I know that navies are really interested in this technology. It's normally quite covert in terms of what they disclose about it. But the other areas that AUVs are being used is in research. And I was working with British Antarctic Survey with Boatface. My team was part of the design of the vessel and the equipment providers for it. And of course, BOATY is the name of the British Antarctic Survey AUV that are going to be used for science experiments. So it's pretty revolutionary in science as well as in the naval domain as well as the offshore industry. So yeah, good spot.
Thank you, Kevin. One from Bob Doncom. Sticking with the naval theme, if the naval vessel move toward AI human teaming progresses, do you see a minimum viable crew being a natural barrier? And then he adds, similar to IPMS and crew studies.
Hi, Bob. Good to hear from you. Interesting question. So, yes, I mean, normally the limit on lots of naval vessels is the ability to do battle damage and firefighting on board, as well as operating all the systems. So there's a sort of a natural minimum limit. But the Netherlands Navy produced a number of sort of low-cost sort of offshore patrol vessels where they put in quite a low crew in. These were sort of where they sort of operated, I think, more to commercial practices, such that if there was sort of a serious damage or firefighting, if they couldn't control it, they'd abandon. They got rid of the maintainer functions on board and really sort of pulled that to shoreside support, and there was very little that they could do in terms of onboard maintenance other than sort of very basic watchkeeping and operation of the systems rather than maintenance. So I think there has been some work done, and certainly the automatic firefighting robots have been used in with a number of land-based firefighters. And clearly that progression of robotic technology, I think, might be the liberator that might say, okay, actually now I can reduce the crew, bring in more automation and use robotics to help me. And that's going to be a lot better to fight fires using robotics than using humans.
Thank you, Kevin. And Bob also adds that He's asking if there'd be a SIG on artificial intelligence in the maritime world. If there is, great. If not, he's offered to kick one off. So for anybody interested, looks like we've got a new SIG in the pipeline.
Brilliant. That's brilliant. And I'm really pleased that, and actually, there are a number of people that are interested in this particular topic, and I think it's a wonderful topic for the IMarEST to consider getting into. So my colleague Bernard Toomey, who's leading the working group on certification of AI, would certainly become an immediate member, along with a number of other people as well. So yeah, thank you, Bob.
Two questions where perhaps there's an overlap in terms of the answer, Kevin. One from Sajid Hussain. Do you see the forthcoming smart ships will attract more of the new generation of youngsters to become seafarers? And then Swarandeep Chakraborty, who submitted his question in advance of your presentation, has asked, how do you think the current technological advancements would affect the shipping industry? And I think you've covered a lot of that in the presentation. But could we see crewless vessels soon, and how will it attract employment? So the related aspects there is, as technology moves forward, do we see that being more attractive proposition to the younger seafarer? And from a wider perspective, how will it affect future employment in the industry?
So I think it's quite interesting because the opportunity, if you can call it an opportunity with remote and autonomous ships, is that you take quite a lot of the high-tech knowledge on board the ship and you bring that to the shore operating centre. So the challenge is that you've now got a lower skill requirement to go on board the vessel for some of the roles. And is that going to be attractive? Will people in, potentially in much lower skilled and lower paid roles actually also then want the isolation of going to sea? So I think there is a challenge there, because if we do move those high-tech roles to the shore-based centres, then that could be a problem. Certainly attracting people into shore-based centres, that was covered very well by the Farugo presentation, where they saw the ability to for people to be able to come into an office environment, an office style environment, go home to their families, increased diversity, increased inclusion. It was better for mental well-being. So actually remote centres are going to be a great attraction for people, young or old. But seagoing jobs, I think, is still going to be a real challenge. And I'm really, interested in other people's opinions here. So, I think this could be debated for a long time.
Thank you, Kevin. And Tim has got a market proposition for you, and that's Tim Winter. With the fishing industry being one of the riskiest domains of the maritime working environment, what is being done to use technology to improve safety? So is that an area that Rolls-Royce is looking at in applying greater levels of autonomy?
So it was an area for the old Rolls-Royce that I was involved with. We were looking at sort of more automation around winches for nets, and actually also for the sort of navigational routing as well for trawler vessels. You're absolutely right. I mean, North Sea shipping was sort of at the limit of what the UK HSE would consider to be tolerability, with more than one death per 1,000 employees per annum. But I think actually fishing has become more safe in that respect because of the introduction of some technology. So a number of the shipping vessels that I've been involved with the design and the equipment for have become pretty high tech. The levels of investment that go into fishing vessels is quite high, with safety being at the forefront. Will autonomy make it more safer? Potentially. I mean, could you see an autonomous fishing vessel going out to sea? Yes, potentially that could be. Within the next 10 years, I don't know of any active programs going on at the moment, because fishing companies tend to be small companies, so they don't necessarily have the level of investment to invest in R&D technology. So I think it would probably be a government initiative required to actually accelerate the technology into fishing. There won't be fishing companies, I don't think, that will have the money to do it. Good question, Tim. Thank you.
And a question from John Chudley. Coal regs are constructed that in the event of a collision, the judicial system can find the mariner at fault. Who will be held account in the first AV accident?
So I think this is the equivalent sort of to the automotive. You know, do you run over the 5 young men on one side of the road, or the woman pushing a child in a pram scenario? I don't know the answer to this one. I think that the lawyers around the world, the maritime law firms, have been looking at this. There are a number of papers that have been produced that are trying to articulate, you know, where the responsibility lies. Clearly, there's going to be a product liability for the equipment provider for sensors, situation awareness, navigation system. There may be some product liability that will lie at the ship designer, but clearly there'll be somebody that will be operating the vessel as well, and there may be some liability that might be held there. But of course, you could have a remote operating centre in one country, a ship provided from another country, an equipment supplier in another country, with an accident that happens in the open ocean. And it's going to require agreement in the IMO of where that liability lands. I can't answer that question, but it's one which I know a lot of people are asking, and a lot of the maritime law is trying to answer.
Yeah, thank you. And to some extent that addresses a question we've had from Gamasen, who was asking, quick wins could easily be achieved on the small vessels, but for the larger merchant ships, when likely to move towards being autonomous too, commercial versus safety. So again, that's, you know, the bigger safety question, and ultimately who takes responsibility.
Yeah, and I think, as I said in my presentation, that this technology will be accelerated in national waters, in coastal waters. So countries have got the ability, their own flag states, to permit the use of greater autonomy in their waters. And this is why I think the technology, which is already coming into ferries, it will come into tugs, and it will be coastal shipping as well. So I think that's where we'll see the technology get pioneered. And what's good about that is that you're tackling the difficult areas. You're tackling areas which are near coasts. You're tackling areas where it's restricted waters. The currents and the weather can be particularly difficult around coasts as well. So if you can solve the problems in the difficult areas, it makes ocean going probably a little bit more simpler to overcome.
Thank you. And question from James Crabb. How do you see autonomous ships could help us achieve the Paris climate change goals?
So this is, it will be a contributor, but it won't be the single golden bullet. The way that it would work is, first of all, if you can design a ship without any habitability on board, you can design the ship differently, and therefore you can save weight, you can save, you can maximize cargo space. So potentially for the same size vessel, you can carry more cargo. The habitability side of it is an area where you can get rid of a lot of the space and weight requirements for water evaporators and heads and galleys and accommodation spaces. That all goes. So effectively, you've got more of the ship dedicated to cargo, so that's going to be efficient. The other side of it is that you're then conferring the routing probably then to AI type technology, which will then look at the best routing, which will take into account the weather, it will take into performance of the propulsion system at any point in time. It will look at the naval architecture and decide what type of water and wave height and wave periodicity is best and most efficient for that particular vessel. And it won't be, you know, the sort of the gut feel of maybe the master in all of this will not come into play. You'll get that more consistency. We'll be able to slow down the vessel as it comes towards a port and schedule it into ports better. And therefore you'll save fuel and you'll be more efficient in terms of its time maneuvering in and out of the port. So connecting autonomous ships with digital ports is another really big area where we can get it. So it will lead to a efficiency improvement, but it's not going to be the big bang. The big bang is going to come through probably the use of zero carbon type fuels.
Thank you. Just a few more questions. Bob Barnes asks, what were the reasons for the failure to fully develop the WR21 for the Type 45? So for those of us who don't know what the WR21 is, perhaps you could elaborate.
So well, the WR21 is actually quite a successful engine now, running on the Type 45. So it's a recuperated and intercooled gas turbine based upon aero-derivative gas turbines. It's got a hybrid of different technologies embodied in it. So as a gas turbine plant, it's very efficient, very effective. The novelty came with an intercooling circuit which cooled down some of the cooling air in the compression stage, and that created a greater mass flow through the engine, which increased its power. I think the intercooler added several megawatts to the output power. And then it had a recuperator, which took some of the exhaust heat and thermally put that back into the combustion cycle. And that improved its efficiency. And, you know, in a simple terms, over most of its operating profile, it had a similar curve to that of a sort of similar size sort of diesel engine. It was a very expensive engine because of all this technology. It was only ever produced for the Type 45 destroyer. So there's only a small handful of engines that are in service. You know, it had its challenges, which were sort of discussed in a lot of detail at House of Commons select committees, which went through a number of the issues with the Type 45 and its power and propulsion system, including some of the areas around the design of the WR21. But the WR21 went through a sort of a redesign of the recuperator, which increased its reliability. And as far as I know, it's been pretty successful on the Type 45.
Great. We're just coming up to time. There's a comment that the UK government investment seems very heavily skewed towards autonomous cars and other transport, with marine as a poor relative. How can we better engage the UK government? So certainly that's something that the Institute will endeavour to do, to always put forward our informed views on the industry and the sectors. A note of thanks from Roland Rogers, thanking you, Kevin, and IMarEST for such a broad-ranging and fascinating annual conference, and a note from Bob confirming that the AI SIG is now up and running.
Well done, excellent. Thank you very much for your time, Gwyn, and as you say, thank you very much for everybody and their questions and your attention today. So thank you very much.
Thank you.